the matrix of our body is determining to a large extent what kind of tissue we get. I heard a nice statement of a biologist. It said the cells in your arm or your skin have the same genetic uptake as the cells in your eye. But nevertheless, the eye is where the eye is and the arm is where the arm is. And the only thing that determines this is the environment that cell is in. I think gives an exact representation of what the impact of the matrix is on human living cells.
A material can behave beautifully on its inventor's bench and fall apart the moment it's transferred to another lab. That gap between a brilliant idea and a product researchers can actually trust is where most biomaterials die. In part 2, Jan and Matt take us inside the messy, fascinating work of making 3D culture reliable. We'll look at organoids at scale, building quality in from the first batch, and what a CEO and a chemist argue about. Let's continue. Are you juggling the complexities of CMC development while trying to enjoy the beauty of biotech? Have you ever wondered if there's a way to simplify bioprocessing? Welcome to the Smart Biotech Scientist podcast, where we're diving headfirst into the very challenges you face. We're breaking it down, demystifying the jargon, and giving you the keys to unlock your full potential. I'm your host, David Brolman, and I get it. With 15 plus years in the biotech industry, I face the same challenges you do. There's a way to simplify and streamline so you can remove complexity, you can skip trials and errors, deliver without delay your groundbreaking therapy to clinics at market, and still enjoy every single step. Do you want to learn how industry experts and I did it? Grab a cup of coffee and your favorite notebook and pen. Now is the time to take your bioprocessing game to the next level. Let's smarten up biotech. Speaking of partner, Jan, I would love to hear your take because you come from process engineering. Matt, you're a chemist, a typical scientist, shall I say? How does that shared language and perhaps not always shared understanding or different viewpoints, how does that influence how you build your company, quality standards into your hydrogels, and finally interact with your customers?
First of all, yes, originally a scientist, but I have been working a long time in the industry, so I'm very well aware of those quality standards. Previous company I had, we were also ISO certified 13485, so that's not easy. One of the things is start early. It's important because then you create a culture that everybody who steps into the company becomes aware of the fact that this is part of our DNA to do this properly. Secondly, I have a strong belief, especially Matt, but we have also different people in the group now, with Clarissa from the cell part and Georgia, who's recently joined. I want to have different cultures, different views on work, and that by having a good team dynamic, then you can create a culture that really is benefiting not only the company, but we can also amalgamate in that quality standard that is really needed if you will become a supplier of that pharma industry. And our material is going to be part of IND file submissions. Then it needs to be a high quality standard.
Yeah, absolutely. How is that for you, Matt, to have these different perspectives?
I think it's good. So I think you pointed out a nice place where we have a lot of overlap on the characterization and the molecular view and the process. I think one of the first folders we made in the shared folder for MosaMatrix was a QC folder, which I think is to show how scientists, it was scary and exciting at the same time, but we try to build those in so that way we have ways to measure things and we know what's going on along the way. I think that's where we have a lot of the same language and a lot of appreciation. We also are very different. You've got someone who's very business oriented and someone who's very scientifically oriented. It leads to a lot of fun arguments, a lot of battling back and forth of which perspectives to take into account. I think overall it makes the company much better and it also makes us better. I really enjoy having different perspectives on the table and having that open environment where you can debate openly and try to figure the way out. It's not always easy, but it's always fun.
I love that. That's a good way of looking at it.
It's really nice. There are times when, for example, I'm a scientist. I really want to make sure that we know what's going on, try to figure things out. But that's not always what's best for a company. And Jan's very good about, okay, we need to go in a direction now. Let's pick this one. This looks best today. This is what we're doing now. And giving us that clear direction. And I think that these are two strengths that we have, and playing off of each other really works for a lot of startups, but ours especially.
I very much appreciate the different views, especially from the university. A lot of ideas come from that origin. Can be controversial, can be misleading, but it also helps you to make the right decisions in the end. As a group, I mean, I'm not making them on my own. I should make them as a group so that everybody carries this forward as the DNA of the organization. And especially, I try to find a way as a spin-out from university. It's feeding our company, but on the other hand, we can also feed back some to that university. It's not only money, but it's also participating in projects, giving people possibility to learn something from how the business works. And if that interaction works properly, both organizations really benefit from that interaction. And then it's also very fruitful to sit so close to a university as we are at this stage.
What did this path, as you were spinning out the technology of the university, actually enable? Or did that facilitate some of the developments, or how did that work?
University is a very friendly organization. It's University of Maastricht, and especially the Merlin Institute. So what we do now is that they give us the option to use their lab, and we pay for the materials that we use, and especially their very expensive analytical equipment. But recently we have now also a small lab that we use for our own facility. And that's more important to have that quality system in place and start to produce as reproducible materials. But we still will keep using that university lab to experiment, to try things, and to use their analytical tools, definitely.
What has been the most challenging part of this entrepreneurial endeavor and scientific endeavor so far?
As always, as a startup, it's always where do you get the money from? To give you an idea, 1.5 years ago, I was sitting in a flex office with just this computer that I have in front of me and a bunch of digital signed documents that you start a company, and we had almost no money. Now we are with 5 people. We have a reasonable bank account. We have a runway for roughly a year to go. But that's a challenge. I mean, that's a challenge for the 5 of us. Everybody is contributing to get those new funding in. That's always a challenge for every startup. That will keep on going. I'm quite confident that we will get to the next year as well, and to the year after that, either by equity, partly commercialize already some of our materials in collaborations and grants that we are pulling in.
In this challenging funding situation our industry is in, what is some piece of advice you would give a scientist who has a brilliant technology and thinks about how can we make this happen?
I think at a certain point it's important that you step out of the idea that you have a brilliant science, but that you try to match that with what you see as really an unmet need in the industry. It really opened up when we start talking about how do you cultivate your cells, how do you harvest them, what do you like about how it works, and what do you don't like how it works at the moment with your organoid cultures. And then people opening up, and suddenly they're going to give you those arguments that is the hook on which you can hang your product, not only, of course, to the customer, but also to potential investors. And that's a different kind of conversation that you have as a scientist, but it's also intellectually very challenging to get the right information out. But if you have that right, and if you have found the right combination between your product and the market, then it can be a very fruitful combination.
So what I'm hearing, Jan, start with the end in mind, understand the needs of your customer, and then work everything backwards instead of saying, hey, I have this amazing scientific discovery and try to push that onto people.
It doesn't help if you say, I have the best polymer. It helps if you are go to a customer and say, I think I have something that can really help your work to become better or more smarter or give you better results. And of course, then you need to fulfill that promise, of course, with the product that you have made. I don't want to discard that, but the match is the critical part.
I would debate here a little bit. So I think that as a scientist, you have to go out and push your ideas and push your product a little bit. But I think what I learned working with Jan most clearly was that you really have to learn to listen. if you can figure out what people's problems are, and if you can provide a path to solving that problem, it doesn't really matter how great your technology is. If you're solving people's problems, they love it. A good example here is our material. A lot of times we get a lot of traction because it's animal free. Now, that's not how I, as a scientist, designed it, but that's the need that it fits in the market. And those are the type of customers we target now. And I think any new scientist trying to start this, turn on your ears, really listen, and write down what you hear from people. And that'll help you find your ideal customer faster.
How does your technology development look like in the next 5 years? What is your vision?
I think for the coming year it's very crucial that we find some real good collaborations and cement them into the company so that we can really grow on those ones. We have already identified them, I think, where we also can find some commercial traction. A platform technology, as we have, finding investors for that, it's important that we have customers and sales, and especially reliable and trustworthy customers. With that combination, you should be able not only to grow this product, but we have a couple of other ideas that I think are also very fruitful, that we can add them to the mix so that we can offer a broader portfolio for a broader range of cells in the next 2-3 years. And our idea is to break even by 2-3 years from now as a target.
I would add on to that I think now, like Jan said, what's really critical is having that first solid customer that allows us to start really producing materials in a larger application and really get our foot in the door in the market and be validated, if you will, with a customer. It gets more exciting for me, again, where you can start to do a little bit more R&D and a little bit more development around there. And I think that's what we'd like to see happen in the company. So get established and then tackle these new ideas that we have, which are on the back burner for now while we're still getting ourselves validated in the market.
As we are wrapping up, what additional question should I have asked?
I didn't think about this question. This is a good question.
Yes, Jan, go ahead.
One of the things that are important for us is that people know how to find us or are intrigued by listening to this story and want to know a little bit more, because our network is still 1.5 years after starting with a small team. I think many people around that looking for an application like we have on the shelf. I want to work with it, and I would love to hear them and come back to us in a later stage.
For me, I always think a good question is, what are you most excited about right now? I think I answered a little bit in the transition to animal free, but I really think we're starting to get towards a turning point in these fields where we can really start to create living objects from cells and material combinations. And I think doing this for 3D drug models is one version, but then also for cellular agriculture, for engineered living materials. And this area of biomanufacturing, I think, is just in its infancy. And seeing that grow in the future is quite promising. And that's where we want to grow with that, because we think that you need good materials to enable this as well. And we hope it grows quickly, of course, right? And we hope it's exciting as we think it can be. But being able to engineer living objects is a new frontier for the industry and something I'm really quite excited about.
What is the most important takeaway from our conversation?
So for me, it's simple. I really think that the matrix is not in the background. It's part of the biology, and it needs to be part of the process.
Jan, anything you would like to add?
No, I was just encouraging Matt to make that sentence here, because I think it's a very useful one and also very true. I think also in reality, the matrix of our body is determining to a large extent what kind of tissue we get. I heard a nice statement of a biologist. It said the cells in your arm or your skin have the same genetic uptake as the cells in your eye. But nevertheless, the eye is where the eye is and the arm is where the arm is. And the only thing that determines this is the environment that the cell is in. I think gives an exact representation of what the impact of the matrix is on human living cells.
Fantastic. That's a great way to conclude our conversation. Where can people connect with you and learn more about MosaMatrix?
Our website, MosaMatrix.com. You can reach out to Jan Hunik at MosaMatrix.com and Matt Baker at MosaMatrix.com. And we're all both on LinkedIn, so that's also a good source to reach out. We are welcoming requests, encouragement, and investments.
Smart Biotech Scientists, there you have it. I will leave the links in the show notes. Please reach out to Matt and Jan. And thank you very much for being on the show today. It has been a great conversation.
Thank you very much, David. It was a pleasure.
Thanks, David. Appreciate it.
When the material environment becomes something you can tune, measure, and trust, 3D cell culture stops being an art and starts becoming a discipline. Jan and Matt showed us what it takes to get there. Talked about animal-free, reproducible, and built for the researcher who needs answers they can stake a program on. That's where drug discovery is heading. If you enjoyed this episode, please leave a review on Apple Podcasts or your favorite platform. And thank you so much for tuning in, and we'll see you next time.
All right, smart scientists. That's all for today on the Smart Biotech Scientist podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. If you enjoyed this episode, please leave a review on Apple Podcasts or your favorite podcast platform. By doing so, we can empower more scientists like you. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.